Hello, my name is Jana, and this week what I'm going to be talking about is random sampling using Excel and using the RAND function in Excel and how this can really help you. But very first step you really need to do is understand what is a population. So when you are running a humanitarian or a development program and you want to show results or impact, or you want to show a baseline if you want to put a proposal together, often what you'll want to do is say, we had this much impact, so 70% impact on this indicator, or, our baseline is 30% of people do this behavior, and actually we want to change that to 50% of people do that behavior. And so what you're going to need to do is survey people or assess people to understand what is your baseline of that indicator, and then what is your end line, or what is your post-impact indicator. What results have you achieved through running your program? So what you're going to need to do is do a random sample, because you could just go out and ask 100% of people what they think or what they do or what they know. So you might be monitoring knowledge or attitudes or actually behaviors or practices. But that's going to cost you a lot of money to survey every single person. And it's also going to cost you a lot of time and resources. So what people will do is choose a sample of the population and just survey some people, and then make an assumption that because, 30% of the people we surveyed, which was just a sample, had this behavior, then we can assume that the whole population has that behavior. But in order to do that well, you have to take a truly random sample. If you don't take a random sample, your results basically just apply to the people you surveyed. They don't apply to the whole population. So it's really important that you understand what your whole population is. So if you're running a program and, for example, you train people, your population will be all of the people you trained. So for example, if you run a training, once each month for 12 months, and each month you train 10 people, then at the end you will have trained 10 people in the first month, 10 people in the second month, etc., 120 people by the end of the year. Your whole population will be 120 people. If you want to then do an endline survey with those trainees, you don't have to go back and survey all 120 people. You could actually choose a random sample of those people and just survey some of them. But if you do the random sampling well, then the results will be applicable or generalizable to the whole 120 people. So it gets a little bit complicated, but the very first step in taking a random sample is defining your population. So what if you do community work in 5 communities? Your entire population then would be all of the people that live in all of the 5 communities, okay? So that, if you're doing community work, can be very, very difficult to get because we don't just have lists of names often when you're out in quite a rural program area. You might not just have a list of all of the household names of all of the people. So just forget about that, and we'll... No, don't forget about it, but actually there are different ways to do that. So you might be able to get community mapping, or maybe there's the village council or something might have a record of all of the people. So you need to kind of go searching for how do we get the most complete list of all of the possible people that are in our population. Another example would be if you do distributions. So if you are going out and distributing cash, or you're distributing hygiene kits or something like that, then all of the households or all of the people that you distribute to, so it depends on if your distributions are to households or if they are to individuals, all of those entities would become part of your population, and you have to list 100% of them. So I've just shown, I've just made this Excel template where in the first column you need to list all of the households, okay? So, or all of the trainees, or all of the names of the people who are in your population, okay? And you just put them right down that whole list. I'm making a fake example here, but in my population, I have 300 people. And I'm just calling them ID. Now, you could put names, household names. You could put ID numbers. If you're sending this around, you might not want to be emailing people's names around. So it depends what your list looks like. But just make a list of your entire population in one column. And then in the second column, what we're going to try to figure out with a random sampling methodology is, should we interview this person? Okay, so should we interview ID 1? Should we interview ID 2? Okay, and by the end of this video, what you'll have actually is, yes, this is your final list. So step number 1, after you've defined your population, you've put them all in a list. Step number 2 is actually going to figure out your sample size. Okay, so fill in the yellow cell. So what do you want your total population, or what is your total population size? So for me, it's 300. And what confidence level do you want? So how confident do you want these results to be? So confidence level is like for saying, for example, if I was to repeat this survey over and over and over and over and over and over again, then 95% of the time, the results would give me the same results. Okay, so if I did this 100 times, if I did this survey 100 times, 95 times I'd get the same results. 5 times I might have some crazy results out there, and my results aren't going to be accurate. But 95% of the time, my results are going to be applicable to the whole population. That would be awesome. Okay, so that's the confidence level that most people actually choose. Sometimes you can say 90%, but and if you want to be really accurate, then some people will put 99%. In humanitarian context, I would say somewhere between 90 and 95%, as long as your donor is quite happy with that percentage, it's totally fine. And the second percentage you want to identify is your margin of error. So if you want to be right 95% of the time, plus or minus 5%. So it means if your result came back that 30% of people have impacted their behavior, you're 95% confident that it's 30% of people, plus or minus 5. So it could be 25%, it could be 35%, but our results came back 30%. Or if your results came back 42%, minus 5 would be 37% to 47%. Okay, so that's kind of the range that you're giving, is the plus or minus 5%. So you know that somewhere within that 10% range, your numbers are accurate to that 10% range. Now, the margin of error, as you get more precise, so if you only wanted a 1% margin of error, you're going to have to interview more people. If you choose a 10% margin of error, you will have to only interview fewer people. So it depends on your budget, on your time constraints, on kind of what your donors need, but you don't want your results, your margin of error to be so big that your results are meaningless. So a really good number to choose would be 5%. So 95% confidence interval with 5% margin of error, or confidence level with 5% margin of error, is a very typical survey confidence level that we would be quite happy with, and that most donors are going to be really, really happy with. Okay, and then what you need to do is go to find a sample size calculator online. So I use this one, so I'll just click this in the template and it'll just take me to this website. So there are tons of sample size calculators online, and they all basically do exactly the same thing. So my confidence level is 95%. I said my confidence interval is 5, and my population, which we've defined in at the very beginning, is 300. And you just press calculate, and the sample size needed is 169. So I'm going to go back to my template, and you see I've filled that in already. So my sample size is 169. Whoops, 169. And then we're ready for step 2. So that's given us, it means we just have to go out and interview 169 people who are randomly selected, and we will have results that are generalizable, so we don't have to do a census to find really reliable results. Okay, and so back in our template, step number 2 would be when you go to do a survey, sometimes people aren't available. So there are no-shows, they have gone on a holiday, or they're sick, or they're not available for the survey. And you can estimate a percentage of no-shows, okay? And fill this in. So if I say 50%, this template, I've just said that it should automatically put the sample size there. And if we have 15% of no-shows, then we should add 25 extra people to our interview list. So this is just a formula that multiplies 15% by 169. So it means 25 extra names should probably be sampled just to account for people who aren't available. And then the total number of people in our interview list is another formula which just adds 169 and 125. Which gives us 194 should be the total number of people in our interview list. Now, if we had only chosen 10% of people are probably no-shows, then it will recalculate this and say, well, you only need 186 people on your interview list. So what you need to do is have kind of a good percentage here that's very applicable to your setting. So if you're doing phone interviews, often people don't answer their phone if they don't want to be surveyed. So your no-show list might be a little bit higher, or no-show percentage might be a bit higher. If you're going to people's houses, actually they might be home quite a bit more frequently, or you can wait around to kind of get them. But you really need to be able to just kind of use this one. It shouldn't be too high because it does change a bit the end sampling, and you need to be very committed to, if that person could be available for an interview today, we really should try to interview every person on our list. So that's step number 2, is just determining the number of names that we need to add to our sample size in order to account for people who aren't available on the day of the survey. The step 3, so moving down to the next tab, is figuring out the probability that any person on your population list could be interviewed. So if you have 186 people on your interview list, okay, but your total population is 300, we just do this formula where we divide 186 divided by 300 is 61.967%, okay? So that's the probability that each individual person should be interviewed. So for person number 1 on your population list, there's approximately 62% chance that they'll be chosen for an interview. For person number 2, 62% chance that they'll be chosen for an interview. So each person has this probability that they'll be chosen for an interview. Okay, so that's a very simple one. In my template, it just automatically calculates that. So step number 4 is actually then writing a formula that uses that probability that we just calculated. And it uses something called Bernoulli's distribution. And it uses Excel's RAND function to create a random number. So RAND, if we just say equals RAND and open bracket, close bracket, and we press enter in Excel, it will generate a random number between 0 and 1. Okay, so, and basically because it's random, we should have the same it's just as likely that it will show 0.1454812002, whatever, as it will show 0.19, as it will show 0.87, as it will show. So it's because it's random, it should show all of those numbers an equal amount of time. If you just continued calculating over and over and over and over and over again, it will spread those numbers out evenly. Now, how do we actually use this? So if you say if, so using Excel's if function, so if we put equals if and an open bracket, it'll ask us for a logical test. So if, and then we're going to get Excel to calculate a random number. So if that random number is less than or equal to our probability, so 62%, it means any number that's under or equal to 62% generated by RAND, then we should definitely interview that person. And if it's over, so if it's 63% or above, then we should say, no, we're not going to interview that person. Okay, so it's the if statement, and we say the logical test is generate a random number and check if it's under or equal to 62%. And if it is, then yes, we'll interview that person. And if it's not, then no, we won't. And press enter. Now, I've just put that very same formula here, okay? And all you need to do is then drag that all the way down to the bottom of your population list. And it will make a list of who you should go out and survey. And this is a truly random sample. But because we use Bernoulli's distribution, actually it should be saying yes 62% of the time. Okay, so we'll go and check that. So that's step number 4, is we actually just create this yes and no for each person in our population, or each household, or each entity in our population. So the next thing you want to do in step 5 is copy and paste that. So every time we press enter, all of these formulas are going to change every single time. So if I do this again and you watch, the yeses and nos have changed. So the formula recalculates in every cell every single time there's a refresh, okay? Which means your random selection will be lost, okay? So what you need to do is copy the entire list, okay? So you can copy it. And in step 5, if you just right click here in A1, go to paste options here, and you paste as values, okay? So in here, we no longer have a formula, we just have yeses and nos, okay? So which it means it won't change, okay? It's now not changing. So that's an important step if you want to be actually able to show someone how you did this. Now, step 6 is creating a pivot table. So what I'm going to do is then select from step 5. So these are just the values. This isn't the formula. You want to insert a pivot table. Okay. And a dialog box will pop up. We want to say, put it in an existing worksheet, and we'll put it over here in step 6. Okay. Just put it in A1 and click OK. And we want to click, should we interview this person? Okay, so it will show no's and yeses. And then click on that again and drag it into the values. And it's actually just going to count how many no's and how many yeses. Okay, so it's saying that from our random generation, this has given us 194 names. Okay, 194 yeses. Now, if we go back to interview probability, you can say we only need to interview 186. So actually, if you go out and try to interview 194, maybe that's fine. But actually, if we go back to step 4, we could just refresh this. And if that's a little bit high, we could just refresh this. Copy and paste special, and then in your pivot just refresh those numbers. Okay, 188. So actually that's really close to so it's saying that there are 188 yeses now in that list and 112 no's, and 188 is very close to the number we're looking for. So interview around 186 people. So I would say I'm quite happy with the number of people that showed up on that list. That's the right amount of people. It's totally randomly selected. I have had no impact on who is a yes and who is a no. Okay, so I haven't said, well, I only want people from this location, or I only want, men or women. Okay, so I've given no bias to this selection. It's just like I've randomly chosen yes or no for each person, except I have tweaked it so that yes comes up 62% of the time, so that we do have a list of the right number of names at the end of it, okay? And then once you have your pivot table, what you want to do is then, so I'm gonna copy this, paste that list of names from step 5 here, and I'm gonna add a filter. So if you, let me just add a filter here. So go to data and then filter, and it will just add these little drop down boxes. And what I want to do is not select all. I only want to select the yeses. Okay. And then I'm going to copy all of these yeses. And I'm going to go to step 8. And I'm going to paste them here. So this is only the yeses now. And I can then give each interviewee a number. Okay, and I've just copied and pasted that down, so you can see the list now has 188 names. Okay, so that is exactly how to do a random sample if you have the entire population list already in Excel using the RAND function. And what I just want you to watch out for is, number one, have you truly captured everyone in the population? So if you are trying to make a list of everyone who lives in a community, what about minority groups who aren't represented on the population lists? Or what about people who are seasonally living there and not? So have you truly captured your population? You also need to really think about not adding or removing anyone from that final list just because of how you feel. So if you think, I don't really want to survey that person because they've had quite bad results or the no impact, those results are just as important as saying that there is lots of impact. The second thing I wanted to say is that the no-show estimate is important. You don't want to make it too high. It does add a little bit of bias to your end results because, if all of the people who are no-shows are because, they're non-existent or they don't answer their phone, something like that, then actually you do produce a certain amount of kind of self-selection bias. However, so you don't want that percentage of no-shows to be too high. But it is important if you do want a random sample that's big enough for you to get the results that you're looking for. Number 3 is at the end of the survey, go back to the sample size calculator to calculate your actual margin of error. So you have 188 people that you've put on the list. At the end of the survey, you might find that you have interviewed 180 of them. Okay, so based on no-shows and unavailability, you could go back to the sample size calculator, and it's just open right here. Your sample size, say if you interviewed 180 people, your population was 300, and your percentage was 50, which is what you should put in there. If you calculate, your confidence and interval is 4.6. So you're actually confident of the results, 95% confident, plus or minus 4.6%. So you've actually done a little bit better than your original plan. Likewise, if only, say, 140 people were interviewed, if you calculate that, your confidence interval is only 6%, which isn't quite as reliable. And the last point I want to make is don't intentionally try to add or leave out an interviewee from the final list. If someone had great results or someone had terrible results, even though you may think they're an outlier, they do help to skew the results appropriately. Because we've done a random sample, we are trying to find, the averages and the means and the medians, and those extreme numbers help in building that bell curve that's really important for your final results. So, try to be as inclusive as possible. Don't put your own bias or judgment on who you should interview or not. This is a random sample. So I'll leave it there. Hopefully that was really helpful, and you can now go and use a random sample using Excel, the RAND function, the if function, and have lots of fun. Okay, bye.